Welcome to Lesson 5 of the topic Matter 2. Our title for this lesson is Writing Ionic Compounds. Our question for this lesson is what is an ionic compound and how is it formed? The keywords for this lesson are atom, element, compound, ion, positive, negative, and electrostatic. The first thing that we need to do for this lesson is to complete a knowledge check, so make sure that you pause the video and give yourself enough time to answer all 8 questions before the answers appear. Here are the answers. So for number 1, the charge of non-metal ions is negative. This is because they gain electrons when they become ions. Therefore, because they are gaining electrons that have a negative charge, then they are gaining more negative charge. The force attracting ions together is electrostatic forces. This is a force between oppositely charged ions, and it forms an ionic bond. The overall charge of an atom is neutral. An atom has no overall charge because it has equal positive and negative charge. When atoms become ions, they gain a charge by either losing or gaining electrons. Now, metal ions are positive ions because metals, they lose electrons, meaning they lose negative charge, meaning that overall they become positive. The position of charge when writing the symbol for an ion is superscript. This means that we write it above in small. So we pretend that it's flying a little bit and we write it up above and in very small writing. The name of the electrons in the outer shell is valence electrons. And when it comes to naming ionic compounds, we start with the name of the metal first. So remember that we include a metal and a non-metal in terms of ionic compounds. We always start with the metal name first and then the non-metal ion name afterwards. For number 8, a chlorine atom becomes a chloride ion, so the name changes slightly, and you'll see that quite a lot with those non-metal ions. Make sure that you mark your work and give yourself a score out of 8. Make any corrections that you need to make with a different coloured pen. So now we are going to talk about ionic compounds. So compounds are made when more than one type of element is chemically combined to another. Ionic compounds are formed between positive metal ions and negative non-metal ions. So we've already been studying these types of ions. Metals, when they lose electrons, they become positive ions. Non-metals, when they gain electrons, become negative non-metal ions. Because of the opposite charge, they are attracted to each other. So the ionic compound forms because the ions are attracted to each other by a force called an electrostatic force. Now, when naming an ionic compound, we just tend to use the name of the metal ion first and then the name of the non-metal ion afterwards. So it's actually quite easy to name an ionic compound. You just use the name of the metal and then the name of the non-metal that comes together to form the compound. So here we have this diagram. On the left you can see the positive metal ion. On the right you can see the negative non-metal ion. And the electrostatic force is then between them. It forms a bond, an ionic bond, which binds the two together. They're attracted to each other by that electrostatic force. Now, in terms of writing ionic compounds, from the name of the ionic compound, we can determine the chemical symbol for each ion using the table from last lesson. So have a look in your booklet, go back to last lesson, have a look at the table, and you can see that we have the names for the ions, so the metal ions and the negative non-metal ions. We have names for those ions. So we can determine then the chemical symbol based on the metal and the non-metal in terms of the periodic table. So for example, sodium chloride, remember the metal name comes first, so sodium, then the non-metal ion, and instead of chlorine it's a chloride ion. When a chlorine atom becomes an ion, it becomes chloride. It would be Na plus and Cl minus. That's because the charges are to do with the amount of electrons lost or gained. Now we have to work out how many of each ion we would need to make the compound neutral. So the ionic compound must have an overall no charge, neutral charge. Therefore we must have the same amount of positive charge and negative charge. So just like atoms, ionic compounds, so a metal ion and a non-metal ion binding together, that compound needs to be neutral. So if they are not equal, then we can add more ions to the compound until they do become equal. So for example, if sodium was Na2+, to make up two negatives, we would need two chloride ions. We're going to talk about that in a bit more detail, but for now, that is the level that we are at. So we have some examples here. We have sodium chloride, so it shows the names of the ions, the symbol for each ion, the charge of each ion, and then how many we need. And this then gives us the formula using the symbols to show how many of each ion is needed. Our second example is magnesium chloride. Now again, it gives us the name of the ions, gives us the symbol of the ions with the charge as well, the charge of each ion separately, and then the quantity of each needed. So this time we need a second chloride ion to make the total value 2 for the negative charge. Because we've got only one magnesium, but it's got a charge of positive 2. For our ionic compound, we need to make it neutral, which means the same amount of each charge. Because chloride ions only have a charge of -1, we need 2 of them to make up the overall neutral charge. We need 2 positive 2 and negative 2. So we need 2 of those chloride ions to make up -2. Now to show that we need 2 chlorides in the formula, we write the number 2 as subscript. Now you've heard of superscript, that's the above in small. Subscript is then below in small. But we don't write the subscript number 1 if there is only one ion in the formula. So for example with Mg and NaNCl, there's only one of those ions, but we don't have to write 1. We only write if there's more than one. With this idea in mind then, and using the table of ions and their charges, have a go at filling the tables in, showing the ions that make up each ionic compound, and how many of each that we need, and then the formula of the ionic compound. Have a go, pause the video to give yourself enough time to answer all of them before the answers appear. So here are the answers. You can see that I've filled in then all the gaps. So for magnesium oxide, we have magnesium and oxide as our ions. The symbols of the ions, Mg2+, which means the charge of the magnesium ion is +2. The oxide ion, the symbol is O2-, which means that the charge of the oxide ion is 2-, which means that we only need one of each to make the charges balance. Remember that we need to make sure that we have the same amount of negative charge as positive charge, which means that we only need one of each ion, which means our formula is just MgO. And remember that we don't need to write the ones in subscript, we just need to write subscript if there are more than one. Leading on to our next example then, we have potassium oxide. So the ions that make up potassium oxide are potassium and oxide. The symbol for potassium is K+, meaning it has a charge of +1 per ion. And we've already looked at oxide in the example above. The charge is -2. So in order to make the charges balanced, because we've only got one here and two here, we need 2 potassium ions to make sure that we have enough positive charge compared to the negative charge. Therefore the formula would be K2O. So if you haven't already, make sure then that you do these other tables as well. So pause the video if you haven't done these before the answers appear. Okay, so for zinc fluoride, we have zinc and a fluoride ion as well. Because the zinc has a +2 charge and the fluoride only has -1, we need 2 fluoride ions to then make up a neutral charge. So the formula is ZnF2. For calcium chloride, it's a similar situation. So calcium has a +2 charge, chloride only has -1, so we need 2 chloride ions to make up the -2 charge. So we've got CaCl2 is then the symbol, the formula for calcium chloride. And the last one is a bit tricky. So we've got aluminium oxide. Now aluminium, the ion has a +3 charge, and the oxide has a -2 charge. Now you might be thinking, why have I then put 2 here and 3 here? So because we can't just then double the oxide, so if we had just one aluminium and 2 oxide ions, we'd have +3 here and then -4 here, which then doesn't equal out, it doesn't balance out. So to get equal sides, we have 2 aluminium ions which make up +6 charge, and we then need 3 oxide ions to make up a -6 charge. So the overall formula for this ionic compound is Al2O3. Make sure that you mark your work, make any corrections that you need to in a different coloured pen. Now we have a knowledge check to complete, so make sure that you pause the video and give yourself enough time to answer all 8 questions before the answers appear. Here are the answers. So the force attracting ions together is electrostatic forces, and these form ionic bonds. It is the attraction between oppositely charged ions. The charge of non-metal ions is negative. This is because they gain electrons. The name of electrons in the outer shell are valence electrons. The overall charge of an ionic compound is neutral, no charge. So the same as an atom, an ionic compound where a positive ion and a negative ion come together, metal and non-metal, it forms an ionic compound with no charge. So therefore, the chemical formula for magnesium chloride is MgCl2. Because the magnesium has a charge of 2+ in terms of its ion, and the chloride ion only has a -1 charge, you need 2 chloride ions to make sure that the compound is neutral, because we need the charges to be balanced. So therefore we have 1 ion of magnesium and 2 ions of chloride. So 2 chloride ions. The chemical formula for zinc fluoride, we have Zn being zinc, and that ion is a 2+ charge ion, so +2 charge. The fluoride ion is just a -1 charge. So very similar then to magnesium chloride, because the zinc is 2+ charge, we need 2 fluoride ions to make up that neutral charge. So the formula is then ZnF2. And remember that we write the amount of ions in subscript, so meaning small below, and the charges should be superscript, so small above. The formula for aluminium oxide is Al2O3, because the aluminium ion is 3+ charge, and the oxide ion is then 2- charge. Now if we had 2 oxide ions, that would create a 4 negative charge, which then would mean there's more negative charge than positive charge, and we need it to be neutral. So in order to make it neutral, we have 2 aluminium ions, which means +6 charge, and then 3 oxide ions means that it has a -6 charge. Now the position of the number that represents the quantity of each ion, these little numbers here, we call it subscript. It just means written below in small. Make sure that you mark your work, make any corrections that you need to with a different coloured pen, and for these ones, make sure that you understand how you get the chemical formula. So how do you know that there's 2 chloride ions? Things like that. So you need to make sure that you understand the answers, especially for these 3 questions. Now there is an extension activity, so please pause the video if you want to give that a go, and we will then go through the answers. So make sure that you pause the video and give yourself enough time to answer the question before the answers appear. Now this question is asking what happens to the valence electrons. Remember, those are the electrons on the outer shell when a magnesium atom becomes an ion. So because magnesium is a metal, we know that it becomes a positive ion, and a chlorine atom becomes an ion, so a chloride ion, meaning that they bond together. So it's asking you the process, what happens when this happens, basically. So why do they bond together? And the reason is because magnesium is a metal, which means that it becomes a positive ion, and we know that it becomes positive because it loses 2 electrons. So the reason why it loses those 2 electrons is because it only has 2 of them, which means it is easier to lose those 2 to get a full outer shell than gain a lot. Because it's lost 2 electrons, it becomes a positive ion, so it has a charge of +2. So this paragraph here is just summing up what kind of ion it becomes, why it becomes that charge of ion, why it becomes a positive ion, and then the charge of the ion. So this paragraph is just about magnesium. Then we might move on to chlorine. So we start with a chlorine atom. It becomes a chloride negative ion when it gains an electron. So this is because it has 7 valence electrons. So it's nearly got a full outer shell. It just needs that extra 1 to get the full outer shell. Because it's gained an electron, it then has a charge of -1. So again, this is just summing up how the chlorine becomes an ion, what type of ion it becomes, which charge, why it becomes that charge in terms of electrons, whether it's gaining or losing, how many, and then it sums up then the charge of that ion. So we now have a magnesium ion with a charge +2 and a chloride ion with a charge of -1. Now, in order for the ionic compound to have a neutral charge, think about it. So the magnesium ion has a +2 charge, and we've just been having a look at formulas and things and trying to make sure that the compound is neutral. Because we have a +2 charge and only a -1 charge, we must have 2 chloride ions to then make up that neutral charge, because it needs the same amount of positive and negative charge. Now, because chloride ions gain just 1 electron and the magnesium ion loses 2, the electrons from the magnesium transfer to the chloride ion. That gives then all 3 ions then have full outer shells. So I've got a picture to show you, and that's this. So here we have our magnesium atom. You can see the 2 electrons in the outer shell. These electrons then transfer to the chlorine atoms, which then become ions. So in the process of these atoms becoming ions, the electrons are transferred. They now have a full outer shell, and they've got a charge because of that difference in the amount of electrons. So the chloride ions are negative because they've gained electrons, and the magnesium is positive because it's lost them. It's given them to the chloride ions. So that magnesium ion is positive. Hopefully that picture really helps cement that idea. Okay, but make sure that you compare your answers to mine. Add in anything that you need to. Certainly that picture might be useful, so you can go back, pause the video and copy that if you need to. But this answer breaks it down. So you look at each ion, you have a look at the charges, and then that tells you how many of each you need. And that gives you the idea of then how they actually bond together. So in terms of electron transfer, okay, who's gaining electrons, who's losing electrons, which ion becomes positive, which ion becomes negative. It all connects, it all brings it all together. Okay, so make sure that you mark your work, compare your answer, add anything that you didn't have. And that is now the end of the lesson. Thank you.